Okay, so what I've done with AntConc is I uploaded, actually I'll show you guys how I uploaded it, because that's the first thing I'm going to do. What I'm going to do is let me clear this, clear all tools and files. Okay, so here I have AntConc just empty, right? And then you guys have access to the L1 English 400 files and the L1 Japanese 400 files. What I'm gonna do first is I'm gonna upload all of them together, and we can take a look at all 800 files. So I have those ready to go. And you can just watch what I do. You don't have to upload yet. What we'll do first is I'll upload the 800. We'll pick some language features we want to compare, and then you guys can upload the English ones and then get the info, and then upload the Japanese ones and get the info, and then run the comparisons. But for the first step one up there, it says choose phrase frames. I always like to use the whole corpus when I choose the linguistic features, and then when I analyze the linguistic features, I'll analyze by subcorpus. So to upload the corpus, I have to have the files on my computer. And I choose File, and then I choose Open Files as Quick Corpus. And then you navigate to where you have the files. So here I have the 400 English ones. Down here I have the Japanese ones. And then here I just have all 800. And here's where it's a little bit weird. So you just have to Control A, and then you select all of the files. So I have all 800 selected inside the folder, and then I click Open, and then it will upload all of those files to the tool. Okay, so I'm not selecting a folder. I'm going into the folder, selecting all of the files with Control A on a PC, and then it loads them up, and it gives this, and it says it's been uploaded. Sometimes I'm like, oh no, something broken, it didn't work. But that's just telling you that they're all uploaded. So now over here, I can see all the files are uploaded. Here's the names of all the files. They're in the AntConc tool. And I can see up here that I have 800 files right up here. Total tokens, that means the total number of words, looks like about 180,000 words. Okay, so a small corpus. Okay, so now I'm ready to start using AntConc to analyze. Inside this corpus, what do you guys think will be the most frequent word? Which word will be the most frequent word in this corpus? What would you guess? Lawrence, what do you think is the most frequent word? Is. That's very good one. Very good guess. Very good guess. Likely wrong, but very good guess. Sally, what do you think is the most frequent word?
Maybe
The? That's a very good guess. Probably right. If this was just like a regular corpus, that would probably be the most frequent word in the English language. Very good. Very good. Very good. Good. So let's take a look here. This corpus is a little bit different because remember we had those prompts about smoking, and then we had prompts about part-time jobs. And here we're also looking at a mixture of L1 English and L1 Japanese English essays, right? So if I click the most frequent word here, what I get might be different from what I would get if I were only looking at the L1 English files. Okay, so if I go, I'm just going to go to this word thing here. I'm just going to click Start. And okay, here, so this is what it gave me. So here we got the most frequent word in this corpus, which is not representative of the English language in general, is to. Just a little bit more than the or a. If you opened up just the L1 English files, somebody want to do that? Do you guys have that? Open up just the L1 English files and then do the same thing. See if, do we get something different? Same, to, the, and. And this one is to, the, and. So here we can already tell that the L1 Japanese are using the word a couple different words more frequently that are bringing them up, the overall numbers. But if you look at the top 10, pretty much the same, right? To, the, and, that, I, of. So here we see the most frequent words. We have words like in, of, the, to. What's the name of those? What are those types of words called, Mary? The, to, of, articles?
Two, no.
To.
Function word.
Very good, function words. That is the correct term. Very good. Those are function words, yes. They don't have much semantic meaning, but they add to the texture and cohesion of. So what do you guys think will be the most frequent 4-word lexical bundles? On the other hand, that could be one. We're talking about smoking and part-time jobs. Part-time job in university, right? That might be something like that. Will come up a lot, possibly. Well, let's see. Let's hit start and see what happens. Oh, there's only 6 that occur at least 200 times. That's crazy. That really reduced the number. Number 1, a part-time job. Number 2, have a part-time. Number 3, to have a part. Number 4, at all the restaurants. 5, for college students too. And 6, important for college students. Okay, so there we go. Number 1, do you think that comes from the texts that are about a part-time job or the texts that are about smoking being banned in restaurants? Very good. Perfect score. Okay, so we can already see some interesting things happening, something that might be problematic. Okay, so number 1 and 2, a part-time job, have a part-time. Probably, there's a lot of overlap between those two. Probably a bunch of those go back to have a part-time job, right? So, if you're a corpus linguist, you have to think to yourself, if I count a part-time job and I count have a part-time, that's actually, a bunch of that is the 5-word lexical bundle, have a part-time job. So if you count those 2, you're double counting a part-time, right? Because a lot of that part-time happens in lexical bundle number 2, and a lot of it happens in lexical bundle number 1. And a lot of it's going to happen in lexical bundle number 3. So you have to decide, do I want to allow for that overlap? If I do allow for it, I should say that. Be very transparent and say I'm counting these 2 times, right? Or you could have some principled approach. For example, if more than 80% of a part-time job comes from have a part-time job, then I'll just put them together and count them as one 5-word lexical bundle, and I'll drop 20% of the remainder. Okay, so you could do that too. So you have to make your decision. You can read other studies on lexical bundles, see what other people do, decide which approach you think makes the most sense, have your reason for your decision, state your reason, and then just go forward with that. Okay, I'm going to lower the frequency down to 100 and see what we get. It is important for, that's a good one. I think it is, there's a good one. So now we can start to figure out which lexical bundles are prompt dependent and which lexical bundles are not prompt dependent. Okay? So we'll know that having a part-time and a part-time job are happening so frequently because of the prompts, but something like I think it is and it is important for, those are lexical bundles that will show up in argumentative essays in general, right? Not necessarily simply because this is about a part-time job or smoking, right? So think that it is important, I think it is important for, right? All those types of things. Okay, good. So those are lexical bundles. Now let's move on to phrase frames. And we'll choose some phrase frames that we want to run some analyses on, to run some comparisons with. So to choose some phrase frames, I'm going to be here at this engram, and I'm going to click Open Slots 1. I just clicked one open slot. So now we'll have that like it is blank too, right? Or something like that. And let's put these back up to 200. Because we're going to get more phrase frames than lexical bundles because of the variability. Let's choose 3 phrase frames to study, to do some analysis of today. And let's have at least 2, we'll choose 3 phrase frames. Let's choose 3. And then at least 2 should be not prompt dependent. Okay, so there, Gary, which one do you guys want? Number 7? Yes? Okay. Perfect. It is blank 4. This will be 1. It is, I'm going to use the plus sign to represent the variable slot. It is blank 4. Okay, very good. Semicolon. Oh, it is blank 4. Okay? Group back there. All the blank in. Nice. Very interesting. Cool. Okay. And I'll choose one. Sally, earlier you said, what was the most frequent word that you said? The, right? Okay. So, the. That's the first word of the most frequent phrase frame.
The blank of the blank?
Very good. It would just be the blank of the, yeah. Good.
Oh, yeah.
The blank of the. Because the definition of a phrase frame will be a lexical bundle with an internal variable slot. Yeah, the blank of the. That is usually the most frequent phrase frame. Here in this one, that's way down at 48 though. That's interesting. I'll do that one then. We'll study that one and see what the differences are. Okay. So what we'll do now then is I would like to let's upload each corpus. Let's search up these first in the English corpus. We'll get their frequencies. And then we'll search them up in the Japanese corpus and we'll get their frequencies. But what do you guys think before we search it up? It is blank for, all the blank in, and the blank of the. Which corpus do you think these phrase frames will be more frequent in? Let's make our hypotheses. Number 1, it is blank for. Do you think the L1 Japanese speakers use it more, or do you think the L1 English speakers use it more? Japanese? English? Okay. So we're going to guess that the English use that one more. All blank in. Roy? English use it more. And Ruby, the blank of that.
English.
English. So you think the English, the L1 English speakers use all of these more than the L1 Japanese? It's good guesses. Very good, very good. Which of those phrase frames do you guys think that the Japanese might use more? The blank of that? You think the Japanese?
The blank of the blank.
The blank of the blank? All right. Mary, what do you think, if you're going to extrapolate this phrase frame to put one word in front of here, which word comes to mind that you think would be up in front of there most often?
4.
Very, very good guess. Anything else? That's correct. That's one of the top ones for sure.
In.
Very good. That's also one of them. Yeah, 4 and in. Yep. Of is also in there too, right? And prepositions, all right? Any preposition is there. But yeah, 4, in, of. Excellent. Okay, so let's load up the English one. We go in here to File, Open Files as Quick Corpus. I'll jump into ENS, select them all, open them up. Okay, you guys go ahead and please load up the English one. And I'll search the blank of the. Gary and Larry, you guys can search it is blank for. And then the group in the back can search all the blank in. So here's how I do it. This is how you're gonna do it. You can go like this. You type in your keywords, type in a plus sign, type in of the, like that, but then you do your own. So I searched mine. Oh wait, no, I'm sorry. I forgot. You gotta go to the quick thing over here, up here on top. So this is how you search individual ones. You go up to quick, KWIC up here on top. You type in your phrase frame. So for me, the plus sign of the, and then I hit start, and then it works. But that's up here in the quick tab. Okay, before, I was in the ngram tab just to find find some phrase frames. Now I'm looking up specific ones, and I see I'm in the quick tab. So you guys will go to the quick tab, go up there to quick, way up there, and then down here, you enter your phrase frame with a plus sign as the variable slot, and then you hit start. Now, with the blank of the, looking at mine, how many instances of it are in? Can you guys see how many times it occurs in the English one? In the English corpus? 66 times. All right, 66. So it says here, 1 to 66 of 66 hits. Okay? And the most frequent words that occur in the variable slot are rest, fact. Okay, so for ENS we have 66 for the blank of the. And it looks like our most frequent fillers are rest, fact. Let's see what else is in there. Health, end, taste, health, end, taste. Good. You're good. That's good. So the rest of the fact of the end of the taste of the majority of the part of the beginning of the. Very good. And then it comes all just kind of individual ones. Okay? So there we go. And good. So Gary and Larry, what did you guys get with it is blank for? How many times did the ENS people use that? 56. Okay. And what are the most frequent fillers? Important. Anything else?
Good.
Good. Mm-hmm. Maybe one more?
Appropriate.
Appropriate. That's a great one. Appropriate. Very good. Appropriate. Excellent. Excellent. And then back there, Sally, what did you guys get for the L1 English speakers of all the blank in? How many times did they use that?
29.
29. 29. It's very few. Okay. And then what were some of the fillers that they used?
All the restaurant.
Restaurants.
Restaurant.
Okay, that's a lot of them. And what comes next after restaurants?
All the things in.
All the things. And what comes after that?
No.
Nothing? Just those two?
Yes.
Oh, wow. So restaurant and things. All the restaurants and things. Okay, so based on this, we can see that this phrase frame, all the blank in, is much less variable. It's much more fixed. There's only a couple different fillers in that. Meanwhile, the blank of the has a wider variety of fillers that can occupy the variable slot. And it also looks like it is blank for has a wider variety of fillers. It's a more variable phrase frame. Okay, good. Very nice, very nice. Okay. Now what I want to do is I want to drop the English corpus and I want to upload the Japanese corpus so we can search the same phrase frames in the Japanese corpus and see how they differ. So to do this, I can go to File, and then I can clear all tools and files. And I'll just select that, and then everything disappears. Now I go to File, Open Files as Quick Corpus, and I'll just go over to the Japanese folder, select them all, move it up. Okay, very good. 57 hits. And some of the okay. Now if I look at these, the blank of that, first it happens a little more frequently in L1 English. It happens 66 times versus 57. Okay, so frequency is different a little bit, and not hugely different. But what's more interesting to me is the fillers that are used. On the English side, they're using the rest of the fact of the health of the end of the taste of the. On the Japanese side, they're using the smell of the number of the profit of the benefit of the health of the danger of the. Smell and taste are kind of similar, so I like to see the smell of the and the taste of the. Smell and taste are connected, so that's good. But it's interesting the difference in the fillers that they're using. Okay, how about all the blank in? Ruby, what was the frequency of all the blank in for the Japanese L1?
162.
Whoa! That's crazy difference in the number there. 162. That is crazy. Okay, good. And what were some of the fillers?
Only all the restaurants eat.
All the rest. So just one. So that's not even a phrase frame then. That's just a lexical bundle. That's not even a phrase frame. Okay, good. Well, that's a very fixed phrase frame, right? Even with on the English side. Okay, good. And Roy and Lawrence, aka Gary and Larry. Don't know who's Gary and who's Larry, but what was the number you guys got for it is blank for?
187.
187. That is crazy too. They're using it like triple. And what were some of the fillers?
Important, bad, and good.
Important, bad, and good. So there's some very important words. There we go. Important, bad, and good. What we'll do, we have the numbers that we need to fill in what's called a contingency table. So it is blank for, Lawrence, how many do the Japanese have? 187. And then all the blank in. Mary, how many did the Japanese have?
162.
162. Okay, so now we have all the information we need here. to run a log likelihood test. Because we know that the total corpus size is down here. So the English, L1 English, they have 90,000 words. L1 Japanese, they have 89,000 words. And we know the frequency. So now we can conduct what's called a log likelihood test. A log likelihood test is a non-parametric statistical test to see if there is a statistically significant difference in the frequency. Okay? So if I'm going to do that, how do I do that? I will, this is, well, actually I think I have a slide for this. I can show you guys a slide. You guys can do this too. Calculate log likelihood. So all you have to do is go on Google and search Racine log likelihood. The guy's name who built this tool is named Racine. What we do, once you got that pulled up, is you're going to use these numbers, 9613 and 89401. These numbers will go into the log likelihood calculator. So corpus 1 is 9613, right? 9613, so I'll go down here, 9613. And corpus 2 was what, 89401? Yep, 89401. So I'll put 89401 here. And then frequency of the word, we'll use frequency of the phrase frame. So how about we check out, we'll go down the list. We'll start with the blank of the, so 66 and 57. So we'll put in 66 and 57. Then we hit calculate. And the log likelihood score is 0.54. 0.54. So that means it is not, there's not a statistically significant difference. So it's about the same, no big deal. Nothing big happening there. Okay? Here's the critical values. So that log likelihood value, if it's 3.84 or more, that means it's a statistically significant difference, right? That P is less than 0.05. If that log likelihood value is 6.63, then it means it's more. Well, it's not actually more, but it's statistically significant if you set your p-value at 0.01, if you have 99% confidence. Okay, so that was the first one. So the first one, we have no difference. Let's look at our second one. It is blank for 56 and 187. We can already guess that there's going to be a statistically significant difference here. 56 and 187. Let's do 56. Let's do 187. Calculate. Our LL value is 76.29. 76.29. If we go back and check their guidance, we can see that that is in the 99.99 percentile of statistical significance. That p-value is very small. Okay, so there we go with that one. Let's look at it one more time. Log likelihood value here, the LL. Okay, very good. And then let's check our last one. So we know with this one here, that this is a difference. And my guess is here, this one's going to also be a different one. Oh, I forgot to write down the log likelihood score. And that was something super small. This one was 76.29. And then the last one, 29 versus 162. Mm-hmm. 103.9. Okay? So we can pop that in. 103.90. Very good. So there we have it. The Japanese use the phrase frames "it is blank for" and "all the blank in" statistically more frequently than the L1 English speakers. So some people who do research in learner corpus studies, might say that the Japanese overuse these phrase frames. They use them too much. Why do they use them too much? Because the L1 speakers use them less. Okay? So some people will say that. Other people will say, why do you have to call it overuse? Because they choose to use that phrase frame, or they choose to use that sequence of words. Why is using it a lot bad? Overuse implies that it's something negative. Maybe this is how they want to speak. Maybe this is how they want to write. Right? So if we call it overuse or underuse or good or bad or whatever, that's up to you. But the fact of the matter is they are using it quite a bit more than an L1 speaker of the language would use it. Okay? So that's good. Good stuff. Now, can you guys calculate, what was one more I want to do? One more phrase frame that I wanted to do. How about "it is blank to"? I kind of want to add "it is blank to." Can you guys please, how about Gary and Larry? You guys, can you calculate the numbers for "it is blank to" in the English corpus? And then you guys back there, can you calculate it for the Japanese corpus, please? Easy. That's done with the log likelihood calculator. We did that. That's good. We see that we only have two significant differences between these right there. Okay, so that's how a lot of people do frequency analysis in their corpus study. That's super simple. So if you were to do a learner corpus study and you wanted to use this as a way to compare frequencies, that'd be good. That would probably just be one step in a deeper study. And then you would do something where you're kind of doing a more qualitative analysis of the fillers to see how they're using these phrase frames, what words are being used. Do the words that fill that phrase frame, are they semantically coherent? Is there like a group of words that kind of go well together? So for example, the blank of the, we see on the L1 speaker side, the rest, the health, the taste, the end, the fact. And then on the other side, we see more about numbers and profits that we don't see. So that would be an interesting distinction between them. But main point is, if we want to get some sort of statistical significance check, we can do that with log likelihood. Super easy to do, and a lot of people use this because it's super easy. So first thing we'll do is we'll talk about corpus or corpora. And I see I already have a stray parenthesis there. I'll just get rid of that. And that's what we'll do first. Then second, we'll move into talking about formulaic language. And then we'll try out some corpus methods for like the last, kind of break it up into 3 chunks. Maybe take a break or 2 or something like that. But our main goal is to take it easy. Oh, question number 1, I would like you guys to work together and then the 3 of you guys to discuss together, is what is a corpus? Using only your brains, don't use your phone, don't ask Gemini or ChatGPT, or don't Google it. Just using only your brains and imaginations. Come up with a 1-sentence definition of corpus for me. If you had to explain what is a corpus. If you don't know what a corpus is, that's fine. Just make it up. Make up something. Just use your brain and imagination for about a minute. Please discuss together, you two.
So in my mind, corpus is like the collecting of different words, saying of the meaning or of the categories and collect it together.
Yeah. Yeah, that's something like, so a collection of text from a specific category. I guess a more specific way to word that is probably a collection of text with that's been selected for a certain reason and within certain parameters.
Oh, let's start with Roy and Lawrence. Roy and Lawrence, what do you guys, how would you define, what is a corpus in a sentence? Maximum two.
I think it's large data set about the frequency of the vocabulary or frequency.
Okay, that's good. So using a large data set about frequency or vocabulary, stuff like that. Yeah, that's in the ballpark. That's very good. Excellent, excellent. And then over here, your group, let's have Ruby. How about Ruby? Ruby, you please be the spokesperson. What does your group say?
Corpus is that collected a lot of text.
Very good. Collected a large number of texts. Right? Very good. That's good. So we got a large number of texts. A large number of texts. Question, Ruby. How large is large? How big is big? How big does it have to be? Is 10 enough? Is 20 enough? Is 100 enough? Is 1,000,000 enough? Is bigger better? Bigger's better. And then those texts, how long are the texts? Are they 100 words? Are they 200 words? Are they 6,000 words? Are they 30,000 words?
Depends on what text you collect.
Yeah, it depends on what, yeah. And then how do you decide which text you collect?
Maybe research on their research question.
Very good, yeah. Think about your research question. Yeah, that's really good. So you got your research question, right? And then what are you trying to answer with your research question? And then you got to think, okay, which corpus can I use? Or which corpus can I create, compile, construct, collect to answer my research questions, all right? Very good. That's good. That's good. And it's very important, right? When you choose a corpus or when you create a corpus, because you can do really nice analyses, but if the corpus that you're analyzing doesn't properly address your question, then all the fancy statistics don't really matter because your data doesn't represent what you're trying to study in the first place. Okay, so that's very important. Good. Yeah. So there's a few famous corpus linguists, about 3 or 4. And then one common definition of a corpus is this: a principled collection of naturally occurring texts. Okay? So important words there are principled, naturally occurring texts. Okay? A principled collection of naturally occurring texts. And then as Ruby, as you said, right, if you have your research question and then you want to use a corpus to address that specific research question, that's where principled comes in, right? What are you trying to represent? Are you trying to represent news articles across the USA? Are you trying to represent news articles across France, right? And then if that's what you're doing, then you might pick some major news outlets in France, choose a time frame, randomly sample within that time frame, and that would be your principled collection of news articles that aims to represent news reporting in France in some time frame. Okay, so then you have your principled collection of texts that are naturally occurring, right? And it aims to represent something. Okay, so represent, principled, those are some key words in corpus linguistics. Principled, representative. Question number 2. What is formulaic language? Using only your brains, no Gemini, or Gemini, as they call it in Japan, no chat GPT, no Google searches. What is formulaic language? Same groups. but this-
Kind of like regular and consistent, like follows certain rules. Yes. And is the same in different situations.
Okay, let's go with the group in the back. And how about Sally? What is formulaic language?
It's a language that has the same words and collect together, just like the English, like the Paris,
Idioms.
Indians.
Idioms, yeah.
Also.
Very good, very good, very good. Excellent, excellent. Idioms, that's a good one. That's definitely. And then what is, without using your phone, can anyone define idiom? What is an idiom? Define it for me. Explain it to me. What an idiom is. An idiom is one, it is formulaic language. It's one kind of formulaic language. There's a lot more than that, but it's a great example. Can anyone define idiom?
A self-contained metaphorical phrase that doesn't make sense out of context.
Yeah, that's right about there. Metaphor. What's a metaphor?
Using one thing to represent another thing in language.
That's good. That's good. That's good. Yeah. Yeah. I would define idiom as very similar. I would probably say it's a phrase where the individual words, you can't guess the meaning of the phrase by the individual words. Right? When you put it together, the meaning is different. You can't derive it from the words, like kick the bucket, right? It's a good example of an idiom. Kick the bucket. The individual words means you kick a bucket, right? The literal meaning. But it means die, right? He kicked the bucket, right? It means he died, right? So the actual meaning cannot be derived from the individual words that make up the phrase. Okay, so if we're talking about formulaic language, such as idioms or other types of formulaic language, how might one measure formulaic language? And now, I just want you to come up with some answers on how someone might measure it. And then don't ask me, what do you mean by measure? Use your imagination, guess what I mean by measure, think about it, and just come up with anything. How could you measure formulaic language?
Searching something on Google or whatever. Sometimes you want to search a phrase and you put quotation marks on it.
I got these two guys in my class, and they both got the same name. They're both named Harunobu. So I told them to pick a name because whenever I say Harunobu, they both look, right? So they call themselves Gary and Larry. And then every time I see you guys, I think about Gary and Larry. So I might accidentally call you Gary and Larry, but it's not intentional. So how might we measure it, Gary and Larry? Tenses? So you would use grammar rules to measure. Okay, that's a good one. Yeah, grammar rules could definitely help to measure that. Excellent, excellent, very good, very good. Then the group back there, Mary, we haven't asked you yet.
Maybe we could search for phrases if they're standard enough, normal enough. But you could also, if there's a way to search the words used before and after, right before and after a certain word, if there's a certain word that very often has like certain words before or after it, that could be a sign that that's a formulaic phrase.
Yeah, it's very good, very good. Yeah, that's absolutely right. Both answers are absolutely right. Mary, what you're saying gets more into the realm of, well, I shouldn't say that. Everything gets into the realm of corpus linguistics when we study language. But there's a specific word, like you said, if you got like a target word, and then search words that happen before or after, that frequently happen before or after, there's a specific word for that. Do you know the word for that?
No.
Okay. We'll talk about that one. I have rather radical views on formulaic language. Probably. I often disagree with other professors on stuff. It's okay. So collocation is the word, what you were saying right there. So collocation is the occurrence of two or more words within a short span of each other in a text. Okay? So usually with collocation, they talk about if you have a word and then the collocate, the word that co-occurs, usually happens within 4 spaces before or after that word. Right? I mean, usually it's like 1 or 2 spaces, but that's the standard operationalization of collocation within 4 words. Okay? Yeah, and that's by Sinclair. Sinclair, 1991. Sinclair is one of the big names in corpus linguistics. He passed away, kicked the bucket, as it were, but a very famous man, really good author, good writer, very good thinker, very philosophical, and he was one of the first people to really bring corpus linguistics to the forefront of linguistic analysis. Okay, and yeah, so that's collocation. Collocation's big. So collocation, one way I like to think of collocation is sometimes if you hear a word, your brain will anticipate which words will come next, right? So if I say, hello, how are, your brain's predicting that I will say you, right, last, because that's a high frequency or a strong collocation with that phrase. Sometimes you might even mishear someone because what you predict the person will say based on collocation and what they actually say are different. And you might hear what you predict you're going to hear, but in reality they say something different. Okay, then another type of formulaic language, well, I'll tell you one thing. I think collocation, DCW, by the way, I think collocation underlies all formulaic language. But when you get into the idea of formulaic language, there's lots of different terms for formulaic language. But I think it all comes from collocation. I think, here's how to go crazy. I think everything we say all the time has some measure of collocation. Language and word choice is not random. Everything we say is embedded in patterns. It's just a question of how strong those patterns are. Okay, so formulaic sequence are word combinations that appear to be prefabricated, stored holistically, retrieved as a whole. All right. So we have set phrases like hello, how are you? That nobody actually says. Okay, then other types of formulaic language are lexical bundles, and these are measured by frequency thresholds. You take a chain of 3 or 4 words and you search them up in a corpus, and do they happen more than, for example, 10 times per million words? If they happen more than 10 times per 1 million word stretch, then that would be considered a lexical bundle. So some examples of lexical bundles are, on the other hand, right, you can imagine that in an academic article, on the other hand, comma, or it is likely that, there's a high frequency sequence of 4 words, or a lexical bundle. And a lexical bundle can be a 3-word lexical bundle, a 4-word lexical bundle, a 5-word lexical bundle. After 5, it kind of starts to fall apart and you don't get many high frequency ones. So 4 is a typical length that people do research on. Then there's phrase frames, and these are basically lexical bundles with an internal variable slot. Okay, so some examples are the blank of the, in the blank of, it is blank that, right? Like it is likely that, it is possible that, it is probable that, right? So this sequence of words here is very frequent, but then this filler, the variable slot, can change, and there will be a couple words that fill that slot more frequently than others. On the blank hand, right? So, Lawrence, on the blank hand, what do you think is the most frequent filler? That one over there. On the other hand, right? On the other hand, that'll be the most frequent. What do you think is the second most frequent? Mary.
I actually don't know.
Oh.
I don't come back with anything. It's my own language.
All right, right? It's crazy to say. Once I say it, you'll be like, oh yeah. On the one hand,
Oh, on the one, yeah.
yeah. Okay, so good. So that's what we're going to do. We're going to talk today about corpora. We're going to analyze a corpus. And we're going to look mostly at phrase frames because they're kind of fun. And that's what we'll do today. Okay, so our goals are to gain a better understanding of how the methodological choice in corpus research can affect our inferences of data in learner corpus research studies. The corpus that we're going to use today is, we'll go back to the idea of the corpus. The corpus that we'll use is a learner corpus where we have 400 essays written by people who speak English as their first language. Doesn't necessarily mean that they're good writers, but that's the group speaking. And then we have 400 texts about the same topic written by people who speak Japanese as their first language. And then we'll compare those and how do they differ, right? That's what we'll work on today. Okay, so that was our goals. What are our goals here? Yes. So then we'll search up some phrase frames in this corpus. We'll pull out some phrase frames that we want to investigate and compare. Do we think the L1 speakers of English use them more? Do we think the L1 speakers of Japanese use them more? And then we'll run a couple statistical tests to see the differences between the groups. We'll use a log likelihood test first. That's an easy one to do. It's very popular in corpus linguistics. Why? Because it's easy to do. And then we'll run a simple t-test, which is also easy to do, but it's less common in corpus linguistics because you can't just use a ready-made tool to do it. You have to organize the data and clean it up a little bit, push a bunch of buttons or stuff like that. Okay, so we'll do both of them, and we'll see if the method of analysis makes a difference in our inferences of the data. Okay, so if I run this one, I might think, oh, these guys use it more to the point of statistical significance. But if I run this one, I might think there's not a big difference between the two groups. Okay, so based on the test, our inferences, our conclusions, might be different, or they might be the same. Obviously, they're going to be different a little bit, otherwise I wouldn't bother talking about it. Okay, so learner corpus research, that's what we're working on, where it is when you compare learner language to that of L1 speakers, right? So if we have L1 speakers of Mandarin, we can how do people who grow up speaking Mandarin, how do they differ from people who learn it, starting out in university as a second language and studying Mandarin as a second language. A lot of people in North America compare English with Spanish because Spanish is widely spoken in the USA. A lot of immigrants and kids who are born, they go to school in English but speak Spanish at home. How does that differ? A lot of things like that. And we can compare learner language of learners from different levels. So first we can do L1 speakers versus L2 speakers, or maybe we want to look at just L2 speakers and at different levels, like beginners. learning English as a second language versus more advanced writers, right? So that's another way we can do learner corpus research. And then finally, we can compare target language output from L2 speakers with different L1s, okay? So does L1 have an influence on L2 English? Are the mistakes that an L1 Spanish speaker makes different from what an L1 Chinese speaker would make, or an L1 Vietnamese, or French, or Italian, or Arabic? Any language, doesn't matter. So we'll look at analyzing English as a second language. English is probably the most widely studied foreign language in the world, right? But it doesn't mean we only have to study English. If people in the future want to do research on Chinese, Mandarin as a second language, on Spanish as a second language, and people learning German as a second language, that's all very welcome and very nice. And part of me, I feel like there's too much emphasis on English to the detriment of other languages sometimes. I would like to see more attention given to other languages as well. Okay, the corpus that we'll use today is the ICNAL corpus. This corpus was put together, compiled by Ishikawa, Professor Ishikawa Sensei at Kobe University. And he had students answer 2 prompts in arguments to essays. Prompt number 1 was university students should have a part-time job. And the students had to argue yes or no. I think university students should have a part-time job because, or I think they shouldn't because. And then the second prompt was smoking should be banned in restaurants. All right. And then people would argue yes or no about that. Okay. So he had, corpus looks like this. It's a small corpus. So on the English side, there's a collection of 400 essays, which total about 90,000 words. And the average essay length is 230 words, a little short paragraph. Okay, and then the L1 Japanese also have 400 essays. The average length of each essay was 225 words, and it's 89,000 words. Very similar word counts, very balanced corpora, subcorpora in this corpus. Okay, so that's what we'll use to analyze stuff. And it's important to remember the prompts when we start to look at lexical bundles, frequent phrase frames or lexical bundles. You'll start seeing, the word part-time job will come up a lot, smoking in restaurant, because of those prompts. Okay, so let's see. It's 10 o'clock now. We'll come back, we'll pull out AntConc. So the next thing we're going to do is we're going to calculate a t-test. And this will probably take maybe 30, 40 minutes. And then we'll wrap up and then we'll call it good. So the t-test is it's called a type B study. So what we did up till now was a type C study. And that's where the whole corpus is the unit of analysis. A type B study is where we have the text as the unit of analysis. So there's a big difference because if we take the whole corpus as the unit of analysis, we just say that all the L1 English speakers use it 56 times. That's just representative of L1 English speakers. But if we use a type B study, then we can calculate averages that will also allow us to have standard deviations or standard errors where we can better reflect the contours of the data, and we can also capture, and here's the big thing, we can capture the similarities, right? So if I say the Japanese students use the phrase frame, all the blank in 162 times, and the English L1 students only use it 29 times. That's a huge difference. And it will probably be a big difference when we do the t-test as well. But what you easily forget with those numbers is that out of 400 people, they used it 162 times. But probably 300 people didn't use it at all, right? So if I say 162 versus 27 or 29, that's a big difference. But if I say out of the Japanese authors, 300 didn't use it, and I say out of the L1 English authors, I'd say 370 didn't use it, 300 and then 370, that difference doesn't feel as big as the difference between 29 and 162. So the type C study ignores all the people who don't use it. But the type B study, not only does it capture the people who use it, it's also capturing all the overlap of the people who don't use it, something that a type C study ignores. So we can use a t-test to try to better understand, better capture the similarities. Rather than focus only on the difference, let's focus on the difference, but also focus on the similarities. So to access a t-test in Excel, do you guys have Excel on your computer? I recommend you guys open up Excel and then go to File and then Options. And then you can click Add-ins and select that from the drop-down menu. And then down on the bottom, there's gonna be like a little Go button down here. It looks kind of like this. So once you get to options, you click on this add-ins, and then you go down here and click this little go button.
Can you do that?
Yeah, I just,
Oh, I see.
So you click add-ins, and click, oh, and then you gotta check the box next to Analysis Tool Pack and Analysis Tool Pack VBA and click OK. Yeah, so here's the Analysis Tool Pack. And then, so you want to make sure that these two are added, and then you click OK. That you should be able to find up here on your Excel in the data analysis. Under data and data analysis, there will be the option for a t-test. So if I go to mine, and I go to data up here, then I have this data analysis little tab over here, and now I have all these statistical packages added to Excel. Okay, so you go to data, data analysis, and then you have all the stuff you need. And that's getting the data ready to run the analysis. Getting the data ready to run the analysis is always a super important, super difficult, super boring part. Actually running a t-test, running an ANOVA, running a regression, running a multiple regression, it's all quite easy because you just push the button and it goes. But you have to have the data set up nicely for it to run well. Lawrence, have you run a t-test in Excel before? No? Okay, very good. So what we'll do is we're going to get something here called, we're going to set our data up in long form data. Okay, so there's long form and there's wide form. Usually, when you make a spreadsheet, the human brain wants to make it in wide form. We want to have a column for each variable. So we want to say like L1 Japanese row, L1 English row, the blank of the column, it is blank to column, that's wide form. We don't want to go wide form though. We want to go long form data because most statistical programs and programming languages like Python and R, Excel and things, they all prefer long form data. So we want to put our data into long form. Getting data into long form is easy, but it takes a few steps. So this is what we'll do. I will put my data into long form for the blank of the. And then Gary and Larry, I want you guys to go along doing what I do, but I want you to do it for all the blank. What you guys were all the blank in? Was that your? Which was your phrase frame?
It is.
Okay, so you guys do it for it is blank for, and then the group in the back, you guys do the same thing but for all the blank in, and then we'll have all the data we need ready to go in long form. Okay. So how are we going to do this? Oh, it is a pain. Okay. So, in Excel, I would recommend, actually, let me show you guys what it looks like in the end. Let me just show you real quick what it looks like in the end. Here's the end, what it's going to look like. So I have here, this is the file number up on top. I have multiple sheets. I have a JP sheet for Japanese. I have an ENS sheet for English. I have a long form. This is the data that we're going to run the analysis on. And then these two sheets, these will appear after we run the analysis. Okay, so I have these first three is what I have. So we'll go file, or we'll have file number, put number here, word count, then the frame that you're looking at for a JP, and then you can do the same thing for ENS or EN, right, for English, like that. So what I'll do, I'll just copy this, and I'll put this one in my new one here. I'll go like this. Copy that in there. My frame is the blank, the blank of the. Okay, that's mine. That's for the JP. And then I'll do the same thing for ENS. Okay? So if you guys can set up yours to look something like this, and then in column C, you'll just have your own phrase frame, it is blank for, or all the blank in it.
This computer have the Easter. I need to log in.
Okay?
Oh, you want to watch mine?
And then in column A, we want to make sure that we have 400 files, data for 400 files. So this is how I would do it. I will go 1, 2, 3, like this. Probably Professor Fung has a better way to do this than I do. Then I would grab these like this, and I'll just pull it down to about 401. And it fills it in the rest like that. Right. That reflects the 400 files. Is everybody okay? Okay, now what we're going to do is we're going to start to populate these columns, okay? I'm going to work first on my Japanese one because I need to pull information out of AntConc to do this. So I'm going to go back to AntConc, and I have the blank of the, but instead of using quick, I'm going to use this tab here, plot. Okay? So I use plot, I have the blank of the down here, and I hit start. So you guys please use plot, and then put in your phrase frame, and then hit start. Now notice, keep track, you guys, it looks like you have the English one here, so you want to make sure to put that in the English one there, right, when we start moving it. Mine's on the Japanese one. You guys are also on Japanese, okay, good. Okay, so that's good. We'll have to do it once for Japanese and once for English. Okay, so if you're doing English, copy the stuff into your English file. If you're using Japanese, copy it into the Japanese. So now what you do is you'll just take this and just select these two rows like that. I'm going to go Control Copy. Then I'm going to run it back over to over here. And I'm going to paste it in. So I'm going to go like this. I think I can just do this. Yes. Okay, change the file headings, but that's okay. Okay, so now I have the number of tokens and the frequency in file number 1, file number 2, file number 3. Okay, so I got all this stuff. Now, what we're going to do is we're going to calculate normed rate. Oh, here's a super important step. So remember, we want to reflect that. Here's all the files that have it. But check this out, only 41 files have it. Now, the rest of these 400, the remaining files all have 0. So we have to put that 0 in there. I'll put in 1 0, hold my cursor here, make it turn into the little black cross, and I'll double click it, and it will fill in all the zeros for me. So now I have my 400 instances are covered. I'll just leave it like that. Column B we'll use to get our normed rates. And now we have this. Okay, now we're going to calculate our normed rates. And our normed rates will show up nice for everything up until 0, because you can't divide by 0. So we're going to do our normed rates, and we're going to calculate. So file 1 has 5 instances of the blank of the in the Japanese texts. And then I'm going to take 5, I'm going to divide it by 209, and I'm going to multiply it by 100, so I can see per 100 words, how many times does this phrase frame appear per 100 words. So this will give me a normed rate. And the reason we want to use a normed rate is because all of these files have slightly different numbers of words. So longer files are more likely to have repeat words. So rather than calculate the raw number, we want to calculate a normalized rate per 100 words. We're going to use 100 because these are very small files. So this is how I'll do it. Let me show you guys how I'll do it. I'll hit equals, I'll hit percent. I'm going to take the frequency there, I'm going to divide it by this one over here. I'm going to put another thing there, I'm going to multiply it by 100. Okay? And this is going to be my normed rate for that file. Now, then I just want to apply that to everybody, so I'll do that thing where the cross here turns black in the corner, double click that, and it will fill in the rest, right? Like that. And then, when I get to my zeros, it says I got this divide by problem, so that's fine. I'm just going to delete all these. Just going to delete all those and replace those with zeros down there. Okay? I'll just replace all those with zeros. Boom. Now I have my normed rates. But, well here, I'll stop for just a moment there with you guys. Okay, has everybody got here? Now here comes another important moment. Okay, here's an important moment. What we're going to do here is I'm going to select all of these. I'm going to cruise on down. I'm going to select this whole row. And then, so I'll select it here and I hit copy. All right, so I copied it. This whole thing's in copy, right? Now I'm going to paste these in here, but I'm going to paste just the number. Because I don't want to paste the formula. I just want the raw numbers in there. So, what's that?
The value.
Okay, the value. The value equals just the raw number.
That's what they see.
Oh, okay, so paste the value in there.
对，他讲数字，因为你们一直
The value in there, you can see here. So So Roy, if you look up here like column E, if I click on a value in column E, it shows me a formula. But now if I click on it in value in column D, then I see just the value, right? So I don't want the formula. So what I'm gonna do now is I'm gonna just delete the formulas. The formulas are gone. I don't need them anymore. I don't want them to confuse me. Now I got the normed rates. Just gonna save it like that. Save. Okay? So now what I want you guys to do is do the same thing, but do it for the English corpus. And then you guys do the same thing for the Japanese corpus. So you gotta go back to AntConc, load it up,
Not 150.
and please repeat the process for the other corpus.
And these change into real. Yes. You just type 1 in real. Here. Type 1 in real. Minus 1. Okay. And use this here. And copy the number to this.
The normed rates again. We'll just do this. Frequency divided by the tokens times 100 equals that. Turn around now to zoom. Next step, here's where we're going to move into the long form data. We're going to take all the numbers we generated, we're going to move them over to long form data so we can do the F test and the T test and calculate Cohen's d. Okay? Probably should be done in about 15 minutes. So I have a tab here for long form, and what I did was I put my group and then frequency. Okay? So my group, I'm going to have two groups. I'm going to have ENS for English, and I'm going to have JP. I'll have EN for English and JP for Japanese. Okay? Now remember, we have 400 files, so I want this EN to go from 2 all the way down to 401 to represent my 400 files. And this is where it gets to be long form data. Okay, so I'm going to go down here to about 401, I think. Okay, so now I got 400 cells filled up for ENS, right? 2 to 401. Okay, good. Now I want to take that data, the frequency data, and I want to paste it into here. Okay, so I'm going to go back to my ENS sheet, take these normed rates, and I'm going to grab all of these 400 normed rates for English. I'm going to copy them. So I go here. Oh crap, don't do that. Never mind, don't do it. Don't do what I just did. What I just did was bad. Okay. I'm going to copy this whole column like this. Just copy it. Just select it on top and copy it. I'm going to go over here to long form. I'm just going to paste her in there. Just going to paste it like this. Control V. Okay? And I can change the name back to frequency if I want. Okay, now if I go down, I should have zeros all the way up to that 401 mark, right? Okay? So now I have my long form data for my ENS, for my English group, So remember, this is group here. Column A is group. Column A is group. Now in the same column, I want to add my Japanese group. So I want to add JP. So I'm going to go down to where the end of English, and starting at 402, I'm going to put JP. Okay? I want that to go, and I think it'll go down from 402 to what? 801, right? For the 400 files there, I believe. So I'll take that out of 801. Now, I'm going to paste in all of the values for the JP one. So what I'll do with this, guys, this is what I'll do for the JP. I got this one here, and then I'm gonna select this guy, and then I'm gonna cruise down to the bottom, and then I'll do a control click. Oh, I'm sorry, I was supposed to do shift click, wasn't I? So I select this one, D2, and then I scroll to the bottom. Well, that one's selected, and then I hit shift click, and then it selects them all. And I copy those. I go back over to my long form, go back to the Japanese one here, and then I paste it in there. And those numbers should match up, my zeros should match up to the other one. Okay, now I got 400 JP files and 400 ENS files, EN files in long form. And this is what I want. I want my long form data. I'll just hit save there. So it's all saved nice. Okay? The next thing I want to do is I want to run my t-test. But before I run my t-test, I have to figure out, do my groups is the data have equal variances, right? Because that's an assumption of a t-test. A t-test assumption is that both groups have equal variances. So I can check the equal variance. That pops. So if you guys don't have this, I'll just delete these tabs. These tabs will appear later. They'll come out like this, okay? So I'll delete these tabs and we'll just run them new. I'll just delete that. And then what I want to do is I want to go to data. I want to go to data analysis. And I want to use an F-test for 2 sample for variances. I'm going to compare the variance of the data, right? So I go to data, I'm into data analysis, and I'm going to choose this F-test, 2 sample for variance. Maybe it says something different in Mandarin or whatever it looks like. Maybe you guys can find it. Okay, so I'm going to select that, select the F-test, 2 sample for variance, click OK, and it's going to ask me to put in the variable range for the first one. So for English, I'm going to be grabbing B2 to B401. I'm going to cruise down here. Okay, so I got my first one in there. Next, I'm going to click down here and do my variable for my range for variable 2. And that's going to be 402. I'll do that shift move again so I don't have to drag the whole time. I'll go down the bottom here. And I will shift like that. And I've done it. And then it says new worksheet. When I run this, I'm going to make a new worksheet. So I'm going to call my new sheet, I'm going to call it equal variances test. I'm just going to name it that so I remember what it is. Because a new worksheet will appear with the calculation. So I got my range 2 to 401, 402 to 801 looks good. It's all good. Okay. And then I click OK. And this is what I get. Comes out with a new sheet. Make it a little bit bigger. Looks kind of weird at the moment. And I remember variable 1, I'll change that name to ENS for English. And I'll change variable 2 to JPN for Japanese. I remember I did it in that order. Okay. Oh. And now, here is the important point. This is telling me that it's 0.03, my p-value is 0.03, which means the variances of the two groups, Japanese and English, the variances are statistically different. They are different to the point of statistical significance, which means they do not have equal variances. Which means when I run my t-test, I need to use a t-test that assumes unequal variances, because the variances between these two groups is unequal. Okay? Normally, when you see this p is less than 0.05, you think, yay, I got a significant difference. And you do have a significant difference, but your significant difference is that the variances between these groups are way different from each other. And a regular t-test assumes that they're not way different from each other. So because they are way different from each other, we can't use a normal t-test. We need to use a Welch's t-test, which assumes that the variances are unequal. And these variances are statistically significantly different, meaning that they are unequal. Okay? So that's cool. So now, I'm going to run my t-test. So I'll do the same thing I did before. I'm going to go to data analysis, but this time, I'm going to cruise down here to the bottom, and I'm going to pick a t-test to sample assuming unequal variances. Okay? I just ran the f-test, and I know that the variances are unequal, so I'm going to assume unequal variances. Then I click OK. And then it's going to ask my variable range. So I'll go back up to the top and put my English variable range in there. Pick you guys first. I'll scroll to the bottom, and then I'll hit Shift-click right here to get all of them. So that's variable range number 1. Variable range number 2 is going to be my Japanese. So I'll click that one. Scroll to the bottom. I get to about 801, and then I will shift, click, variable range number 2. My new worksheet, I'll call t-test. I'll just call this one t-test 2, because I already got it. And then I click OK. And I've done my t-test. Takes a minute for Excel to settle down after running that statistical analysis. Okay, variable number 1 was the L1 speakers of English, so I'll call them ENS. Variable number 2 was the Japanese, so I'll call them JPN. And my p-value is 0.35, so they are not, there is not a big difference with the frame and my group. Yep. And we could have guessed that with the 66 versus 57. Okay? So then, how about you guys? What did you get? What was your p-value on your t-test? Whoa, your p-value is super significant. Yeah, that's very good. How about you guys? Also super significant. Very good. Very good, very good, very good, very good. Good. Okay. So far, we can see that we have 2 different statistically significant differences. with it is blank for and all the blank in. Not the case with mine. Okay? So what we're going to do next then is we're going to calculate the magnitude of that difference. Okay? So the magnitude of the difference is going to look like this. With that t-test, so this is what we had here. This is what we just produced this, right? We produced that something that looks like this. I don't have a statistically significant difference. We're going to take this and we're going to calculate what's called an effect size, Cohen's d. Okay? So the way to calculate Cohen's d is you take the difference in your means and then you take your pooled standard deviation by doing this formula here, and then you divide that by that, and then you get your effect size. And your effect size shows the strength of the difference. So if you have an effect size like 0.6, that's really good. 0.8 is super good. If you have an effect size of 0.01, then you're like, okay, if my p-value was good, but actually the practical significance, the practical difference is marginal. It almost doesn't matter, even though my p-value is statistically significant. So to do this, we want to calculate our Cohen's d. Okay, so maybe around column E in here. Why don't you guys type in this like Cohen's d calculation. We'll do that around column E. And then we'll do our difference in means. So for your difference in means, please subtract the bigger mean from the smaller mean. I'm going to subtract this one. I'll do JPN first because JPN is my bigger mean, right? If you have whichever mean is your bigger one, just subtract that one from the smaller one. Okay, so that's my difference in means. Okay, then I'm going to do my pooled standard deviation. So here will be the pooled SD, standard deviation here is what I'm going to do next. And we calculate that by doing the square root of the variances, the sum of the variances divided by 2. And our variances are right here. So if we go look at our variances, here's the variance in, for me it's in row 5. So if I look at that, again it's the square root of the sum of the variances divided by 2. So I'll put equals SQRT equals square root, like that. I'll add one more parenthesis. I'll take that plus that parenthesis divided by 2 parenthesis. That's my pooled SD. Looks like that. Plus the square root of B5 plus C5 divided by 2. And then my Cohen's d, this is the effect size. My Cohen's d is going to be equals the difference in the means divided by pooled SD, enter. So my effect size is 0.06. Super, super, super small. Very small amount for the effect size, okay? So your effect size will be G5 divided by G6.
D5.
G5 divided by G6. 0.8, very big. Very powerful effect there. 0.56, very good. Very good effect. So now you have, now not only do you have, is this statistically significantly different? Yes, it is, with your Cohen's d of 0.56. So that's a strong difference. You guys have a very strong difference, and you guys have a strong difference. Mine has no big difference at all. Okay? So, with this current set, we looked at two different ways to calculate differences. We had the per corpus approach and the per text approach. We had log likelihood, and then we had the t-test. Here, we got the same answer, we got the same outcomes. We had both ways led to statistically significant differences, if we did log likelihood or if we did the t-test. However, I would argue that with the t-test, we're able to get more information. We got mean scores, we got standard deviations, we're able to calculate effect sizes so we can paint a more complete picture of the data. And I have found on numerous occasions where log likelihood will lead us to a statistically significant difference, but on that exact same data set, a t-test or a per text approach will lead to not statistically significant differences. So you can have the same data set, but get different results based on your method of analysis. So I see personally, if you have the chance, if you can do a per text approach, I see no reason not to do it. You only get, at the very minimum, you get more data, you get an effect size, you get standard deviations that you can report, and that's great. And then possibly you will save yourself from committing what's called a type A error, a false positive, where you say these are statistically different. Yeah, if you do log likelihood, if you do a per corpus approach, they are, but they aren't if you do a per text approach. Okay? Do you guys have any questions? Questions or comments?